Okay, we're going to go ahead and start on 3.3, proving lines parallel. Now, what I want you to do for this section is I don't want you to copy anything down. All your notes, everything I'm talking about, is already in the 3.3 packet. The only time I want you to write anything down is when we get to the practice problems. So right now, all I need is that you pay attention so you understand the difference between 3.3 and 3.2. It's a very small difference, but hopefully you will understand what that difference is. We will start by going back to 3.2, and we had two lines, and we'll label them L and M, and there's a transversal line, a third line that's going to cross both these lines, and we'll call that line T. The other thing we're going to do is we're going to label the angles. So let me go ahead and do that. Again, it doesn't matter what numbers I write down or what order I put them. I could have gone on another order. It doesn't matter. Just make sure you can label them so you understand which angles I'm talking about. Okay, and let me write down all the different angles that you're supposed to know from 3.2. So here are our four angles: alternate interior angles, alternate exterior, corresponding angles, same side interior. Let's start with alternate interior angles. We know from 3.2 that angle 4 and 5 are interior and they alternate from the transversal. And from 3.2 we would say that angle 4 equals or is congruent. We use a little squiggly line, that means congruent to angle 5, and also we would say that angle 3 and 6 are also alternate interior, and those are also equal or congruent. But under one condition: those angles are equal only when the lines L and M are parallel, and you would know that because they give you a symbol like this. So in 3.2, if lines L and M, and I'll write that down, if lines L and M are parallel, then you could then say that angles 4 equal to angle 5, and you could say that angle 3 equals to angle 6. If I was using an if and then statement, that would be it. But now what I'm going to do is I'm going to do the converse of this statement. So let me erase all these things here so I can show you and at the same time do the converse. So what I'm going to do now is do the converse of this statement. If line L is parallel to line M, then these two angles 4 and 5 and 3 and 6 are equal. So if I do the converse, I'm going to state it the other way. I'm going to say if angle 4 equals to angle 5 or is congruent, then I could say that line L is going to be parallel to line M. I could also say that if angle 3 is equal to angle 6, then I could say then line L is parallel to line M. If you notice, what I did is I turned the hypothesis, which would be this one right here from the first statement, and I made it the conclusion. Then I turned the conclusion of the first statement and I made that the hypothesis. So what this is called is the converse. So what we're doing on 3.3 is we're working with the converse. So we're doing the converse of alternate interior angles. So what does this mean? It means that if angles 4 and 5 are equal, then you're saying that lines L and M are parallel. So you're working backwards. You're saying that because these angles are equal, 4 and 5, then you're proving that lines L and M are parallel. Same thing with angles 3 and 6. If 3 equals to 6, so if they have the same value, you are proving that lines L and M are parallel. So this is called the converse of alternate interior angles. Then we have alternate exterior angles. This is going to be called the converse of alternate interior angles. That is saying that if angles 2 and 7 are equal, then you're proving that lines L and M are parallel. You also can prove that the lines are parallel if angle 1 is equal to angle 8. So you're proving these lines are equal if any of those pairs are equal. Corresponding angles. Again, it's called the converse of corresponding angles. This is saying that the corresponding angles, those happen to be number 2 and 6. If those angles are equal, you're going to prove lines L and M are parallel. Or if lines 1 and 5 happen to be equal, then you're proving lines L and M are parallel. Or it could be 3 and 7. Or it could be 4 and 8. If any of those pairs, and corresponding angles are 4 pairs, if any of those 4 pairs are equal to each other, you're proving that lines L and M are parallel. And the last one is the converse of same side interior angles. Those angles would be 3 and 5. Or it could be 4 and 6. But there's a difference here. The converse of same side interior states that if these add up to 180, remember, same sides are supplementary. They add up to 180. So the statement would say, if angle 3 and angle 5 are supplementary, meaning they add up to 180, then you're going to prove that line L is parallel to line M. Same thing with 4 and 6. You would write the same thing, except you would say angles 4 and 6. If 4 and 6 are supplementary, then you're proving that lines L and M are parallel. So that's called the converse of same side interior. So let's go now to your notes. Converse of alternate interior angles theorem. If two lines in a transversal form alternate interior angles that are equal, congruent, that's what it means, congruent, it means they're equal, then the two lines are parallel. So you're working backwards. If these two are equal, then you're proving that the lines are parallel, line and M. Converse of alternate exterior angles. If angles 1 and 7 are equal, then you're proving that lines L and M are parallel. And same thing here. Converse of corresponding angles. If you could say that angles 2 and 6 are equal because they're corresponding, and if those angles are equal, then you're proving lines L and M are parallel. And finally, same side interior angles. Converse of the same side interior angle states that if you see these angles, the interiors, like in this example, 3 and 6, these are same side, they're interior. If these add up to 180, meaning that they're supplementary, then you're proving that the lines L and M are parallel. Now let's use these theorems to help you solve some of these practice problems. So now let's look at problem 1. Which lines are parallel if 1 and 2, these angles are equal, they're congruent? So what I'm going to do is I'm going to erase the top part so that we have less lines. We have too many lines around. So I'm going to focus on angles 1 and 2, so I'm going to erase the top part. What you have here now is two lines. These were lines A and B, and then line M. So line M is going to be my transversal, the one that crosses the two lines A and B. Now, if we look at angles 1 and 2, those angles are going to be corresponding angles. Okay, if that's a little confusing to you, you can kind of view it this way. You got two lines like this, and then the third one coming by. So this would be M. This is your A and B, and this is angle 1 and angle 2. So angles 1 and 2 happen to be corresponding. And because they are equal, and correspondings are equal only when lines A and B are parallel. So we are going to say that lines A and B are going to be parallel using the converse of corresponding angles. Okay, let's look at now the second one. So same thing, which lines are parallel if 4 and 1 are equal to each other? So let's locate 1 and 4. Here's 1, here's 4. Okay, so if I ignore this part right here, I'm just going to scratch it out. That means that 1 and 4 are alternate interiors. If I make line A my transversal, which is this one right here, and then I make these two my two lines that are crossing. So if these are alternate interiors, we can assume, and we make them equal, then we're going to say that line L is going to be parallel to line M using alternate interior angles, or in this case, the converse of alternate interior angles. So for problem 2, we're going to use algebra. What is the value of x for which A and B are parallel? So now they're telling us that they're parallel. So they're telling us these two are parallel. So given that for which these are going to be parallel, that means we got to look at these two angles. So these two angles, 2x plus 9 and 111, those happen to be same side interior. Same side interior are supplementary. They add up to 180. So we're going to go ahead and say that 2x plus 9 plus 111 has to equal 180 because those angles are same side, and same side are supplementary. So we're going to go ahead and solve for x. So we have 2x plus 120. 120 is 111 plus 9. It's going to equal to 180. Subtract 120 on both sides. And so 2x is going to equal to 60. Therefore, x is going to equal to 30. Now, for what is the value of w for which C is parallel to D? So they're telling us these two are parallel. Because they're parallel, we're going to go ahead and take this angle, 55, and we're going to take this angle, 3w minus 2. Those happen to be corresponding. Corresponding angles are equal. Okay, the only ones that are equal to 180 are same side. Everything else, alternate interior, alternate exterior, and correspondings, what we have here, are equal. So we're going to go ahead and say that 55 degrees is going to equal to 3w minus 2. These angles have to equal each other. So here's our equation. Now we're just going to go ahead and solve for this. We're going to add 2 on both sides. We get 57 equals 3w. Divide both sides by 3. And w equals 19. So that's how you solve these letters. Okay? They tell you that they are equal, so you're doing pretty much the same thing as 3.2. Don't get confused by it. Okay? Alright, so that was the last problem. If you have any questions, bring them up tomorrow, and then we'll see you till then. Alright?